Once considered a planet, Pluto is now classified as a dwarf planet, but its mysteries continue to captivate scientists.
If the spacecraft wasn't back up and running by the time we flew past Pluto, our 9-year wait would have been for nothing.
Recent discoveries by NASA's New Horizons probe have revealed surprising and unexpected activity on this icy world.
Active geology on Pluto, right now, something so far from the sun should just be a cold, dead world, but it's not. It had this living, breathing heart.
From towering ice volcanoes to potential subsurface oceans, Pluto is far more dynamic than previously thought. Join us as we explore these fascinating findings and delve into the possibility of life beyond our solar system. Pluto's fascinating mysteries. Pluto, once known as the 9th planet in our solar system, has always fascinated scientists. Now, new images have revealed something unusual about this distant world, hinting at a major shift in our understanding of its history. But what exactly did they find? Keep reading to find out. Pluto, an icy world with a core of carbon monoxide and nitrogen, was the first object discovered in the Kuiper Belt and remains its largest known member. However, after similar-sized objects were found in the Kuiper Belt during the 1990s, some scientists began questioning whether Pluto should still be classified as a planet. The New Horizons mission, a historic journey. In 2006, NASA launched the New Horizons mission, aiming to study Pluto, which was once considered the 9th planet in our solar system. After a 9-year journey, New Horizons reached Pluto, becoming the first spacecraft to explore this distant world. That same year, the International Astronomical Union redefined Pluto as a dwarf planet, but this didn't diminish its significance as a target for exploration. In December 2014, NASA woke up the New Horizons probe from hibernation, preparing it for its close encounter with Pluto and to send back crucial data to Earth. First, close-up images, unveiling Pluto's young and dynamic surface. 5 years ago, NASA's New Horizons probe zoomed past Pluto, giving us our first-ever close-up look at this distant world. The spacecraft unveiled stunning landscapes, including glaciers and towering mountains made of water ice. Despite its great distance, New Horizons could only send data back to Earth at a rate of 1 to 2 kilobits per second, with a total data haul of about 6.25 terabytes. It took 15 months to download all the information collected during its flyby of Pluto and its moon, Charon. But the wait was absolutely worth it. The first images sent back showed Pluto's surface to be surprisingly young, featuring a mountain range that rises 11,000 feet into the sky. This range, estimated to be less than 100 million years old, suggests recent geological activity on Pluto, although what exactly caused it remains a mystery. New Horizons captured numerous images that revealed Pluto's dynamic geology: sharp mountain ranges made of solid water ice, frozen methane dune fields, and the largest glacier in the solar system. These discoveries have revolutionized our understanding of icy worlds, proving that even the coldest, most remote planets can have surprising geological diversity. Now, the probe has journeyed 50 astronomical units from Earth, over 7.5 billion kilometers away. Yet scientists are still analyzing the data from Pluto, leading to a groundbreaking revelation. Pluto may be far more active than it seems. But how did astronomers come to this conclusion? New Horizons images revealed something entirely unexpected and unprecedented in the solar system. The terrain of Pluto ranges from extremely young, crater-free surfaces to ancient regions dotted with impact marks. In one of the less cratered areas, the landscape is dominated by large, humpbacked ridges, features unlike anything seen elsewhere in the solar system. In short, images of Pluto's surface reveal a network of bumpy, elevated volcanoes, with surprisingly few impact craters from asteroids or meteors, a stark contrast to the rest of the planet. Additionally, there was no evidence of plate tectonic activity on Pluto, which is a key driver of mountain formation on Earth. So, what do these findings suggest? They indicate that Pluto's surface was shaped by a relatively recent geological event, possibly a volcanic eruption, occurring within the last 2 billion years. While 2 billion years might sound like a long time, in the context of cosmic history, it's actually quite recent. The research reveals that both internal, endogenic, and external, exogenic processes have contributed to significant and ongoing resurfacing of Pluto's landscape. But that's just the beginning. There's much more to uncover. With a radius of 715.2 miles, 151 kilometers, Pluto is the largest object in the Kuiper Belt. The data suggests that its outer 300 kilometers are composed of water ice, while its core consists of rocky material with an unclear carbonaceous component. Pluto's rocks likely provided enough radiogenic heating over its history to maintain shallow levels of internal warmth. Charon, Pluto's largest moon, is thought to have formed from a major grazing collision with Pluto. Among the many discoveries made by New Horizons, scientists found evidence of a possible ancient ocean beneath Charon's surface and peculiar water ice hills floating in frozen nitrogen on Pluto. A study from 2018 even proposed that Pluto's surface might be coated with a thin layer resembling asphalt. Despite its vast distance from the Sun, some scientists believe Pluto's surface may harbor the essential ingredients for life. However, at its core, Pluto's story is one of ice. Not just frozen water like on Earth, but also solidified nitrogen, methane, and carbon monoxide. One of the most iconic images captured by NASA's New Horizons probe is of a heart-shaped region on Pluto known as Tombaugh Regio, named after Clyde Tombaugh, the astronomer who discovered Pluto. The left side of this region is primarily covered in nitrogen snow, while the right side is dominated by methane ice, adding to the icy, yet fascinating story of Pluto. Pluto's unique volcanic features, Wright Mons and Picard Mons. Pluto's volcanic features have long puzzled planetary scientists, particularly two towering peaks that stand out against the dwarf planet's icy surface. The first of these is Wright Mons, a massive structure approximately 150 kilometers wide, rising nearly 5 kilometers above Pluto's surface, with a central depression that spans nearly 50 kilometers across. The second, Picard Mons, is even more impressive, reaching a height of nearly 7 kilometers and stretching about 225 kilometers in width. Despite Pluto's diameter being just 1/6 that of Earth's, these volcanic features are comparable in volume to Hawaii's Mauna Loa, one of the largest volcanoes on our planet. These colossal structures were first discovered in July 2015 by NASA's New Horizons spacecraft during its historic flyby of Pluto. Located on the southwest edge of the Sputnik Planitia ice sheet, the lighter region on the left side of Pluto's famous heart-shaped feature, these formations have drawn significant attention from researchers. Sputnik Planitia itself is an ancient impact basin nearly 1,000 kilometers wide, characterized by folds and wrinkles in an otherwise flat ice sheet. After closely examining the images captured by New Horizons, scientists believe that multiple eruption sites near each other likely contributed to the formation of this unique terrain. The material ejected during cryovolcanic eruptions, volcanism involving the eruption of water, ammonia, or methane instead of molten rock, likely blanketed the entire area in layers of ice. Interestingly, detailed analysis shows that the surface material in this region is primarily water ice, unlike the nitrogen or methane ice found in other younger areas of Pluto. This discovery further increases the likelihood that cryovolcanic activity played a significant role in shaping this landscape. However, for such volcanoes to remain active, a consistent heat source is required to fuel the eruptions. On Earth, the primary energy source for volcanic activity is the heat generated by the radioactive decay within our planet's interior. In some cases, gravitational interactions with nearby large celestial bodies can also produce the necessary heat, as seen with the volcanic activity on Jupiter's moon, Io. However, neither of these scenarios seems likely for Pluto. Cryovolcanism and the mystery of Pluto's heat source. Pluto is too small and distant from the Sun to sustain such heat through radioactive decay alone, and it lacks any large nearby objects exerting significant gravitational pull. This leaves scientists with a mystery. What could be driving the cryovolcanic activity on Pluto? The answer remains elusive, but the discovery of these massive volcanic features suggests that Pluto's interior may be more complex and dynamic than previously thought. Pluto's neighbors and the rocky material in its core aren't strong enough to generate the tidal and gravitational forces needed to warm its interior. With its rock-hard frozen surface and an average temperature of around 240 degrees, Pluto is so distant from the Sun that it couldn't possibly melt quickly, even with other heat sources. So where does this heat come from? The most plausible explanation is that Pluto retains heat from its formation, likely in the form of a deep ocean beneath its icy crust. Similar subsurface oceans are believed to exist on other frigid worlds, such as Jupiter's moon Europa and Saturn's moon Enceladus. Enceladus, for instance, has shown signs of cryovolcanism, spewing icy material into space and replenishing one of Saturn's rings. Yet, Pluto stands out. No other known planet or moon in the solar system shows evidence of such extensive clusters of frozen volcanoes spread across its surface, combining to regenerate an icy terrain. However, we must remember that the New Horizons spacecraft only had a brief flyby of Pluto, spending just one day in close proximity. This means it's still uncertain whether Pluto's cryovolcanism is ongoing or if these exotic ice volcanoes have gone dormant. If Pluto's cryovolcanism is still active, it would increase the likelihood of discovering a liquid ocean beneath its surface, and who knows, perhaps even life. New Horizons. Current position and future prospects. As of August 2022, New Horizons is 53 astronomical units, AU, from the Sun, meaning it's nearly out of the Kuiper Belt. Although this limits the chances of encountering more objects for close study, New Horizons is in a prime position to observe distant trans-Neptunian objects and monitor space weather. Once the Voyager probes cease communication in the next few years, New Horizons will be the only operational spacecraft at the edge of the solar system. Extending its mission could yield valuable data from this largely unexplored region. There's also potential for New Horizons to capture a new version of the iconic pale blue dot photo, showcasing Earth from an incredible distance. Currently, New Horizons is powered by a radioisotope thermoelectric generator, RTG, which provided about 250 watts at launch. However, as plutonium-238 decays and the thermocouple deteriorates, its power output decreases. By the time of its flyby of Arrokoth, the RTG was generating around 190 watts. This figure will drop to about 150 watts by 2032, which is the minimum power needed to maintain radio contact with New Horizons. Still, mission specialists might extend the service life of some onboard systems using techniques learned from the Voyager missions. The possibility of life on Pluto is indeed intriguing, and further exploration could reveal more about this mysterious world. So there you have it. Pluto, once classified as a planet, and now known as a dwarf planet, remains a fascinating subject of study. The discoveries made by the New Horizons probe have shown that something unusual is happening on Pluto. What does it all mean? It's still too early to say definitively, but the idea of life on Pluto is a tantalizing possibility that deserves more investigation. Only time will reveal what else we'll uncover in this vast and mysterious universe. What do you think? Could there be life on Pluto, or is it just a barren, frozen world? Share your thoughts in the comments below.